Hi everyone, very good evening to you all. Hope you all are doing good. We have a wonderful session today here by Ayyanar. So before we start, we have a few things. Let us go through our code of conduct. We are all here to learn together. So please be respectful of other people's views, understanding of differences, and being kind and considerate in a way you all engage. Please, chat section is open. Please do ask all your questions in the chat. We from the chat section will connect you with all the questions and possibly INR will help you to answer all the questions. So, I would now like to bring in INR for today's session. Hey, hi INR, how are you?
Hey, I'm doing good. How are you doing, Pat?
I am good. So, we have a very good climate here in Bangalore. It's sizzling, it's chilling. Hey, by the way, folks, we all are at Reactor. Me and Ian are at Reactor today.
Yeah, I came in person. I enjoyed the weather and the traffic.
So, hey everyone, before Ayana starts the session, I'd like to tell about this today's speaker, Ayana. Aynar has around 17 plus years of IT experience. He is passionate about learning and sharing knowledge on Azure, Kubernetes, DevOps, machine learning, well architected framework in the cloud. He actively contributes to the Cloudnloud Tech community, which helps the cancer childhood. Oh wow, very great, Aina. It's really great thing that you're doing.
Thank you.
Now I request Aina to begin the session. The platform is all yours.
Thank you. Okay, I'm live. Okay. Good evening, everyone, and good morning if anybody joining from other side of the world. Okay, thanks everyone for joining today. Today's session is about MLOps on enterprise scale using Azure ML. Okay, and myself, Ayyanar Jeyakrishnan, I'm an active Cloudnloud community contributor. I before going to this session, I just speak a little bit about what is Cloudnloud and what is our objective. And it is a tech community started on 2011, and we have a loyal cause of helping the cancer childhood children. Okay, and already this community helped more than 7,000 plus cancer child survivors. And this is a knowledge sharing platform. People can come, learn from the peers, and share the knowledge. And we also help the members to come and contribute at the stage and share the knowledge. Also, we mentor them how to be a good speaker, how to be an active part in a cloud community. Okay, and feel free to join in the cloud community on the LinkedIn. We are very active in a LinkedIn. And if you want to message us, you can message us on the number display here. Thank you. Now let me jump into the session. So the current session today, we are going to discuss about how we deploy the machine learning model in using Azure DevOps and Azure ML Workspace at the enterprise scale. Yeah, it's well and good. And how the enterprise, okay, where we have multiple personas like data engineers, data scientists, machine learning engineer, as well as DevOps team. Yeah, sometimes even the project manager come into the picture. How we work together in agile manner in develop the product. Okay, I say AA product, and also it's very important once the application served by the enterprise need to cover all the important bases of responsible AI and fairness. Okay, and that need to be inclusive in your machine learning model, and that need to be validated before it goes live. Okay, in today's session, we are going to cover about AWS machine learning services as Azure machine learning service, Azure Registry, responsible AI and fairness, as well as Azure DevOps. We touch upon the MLFlow also, how we are integrated. Thank you. And what is enterprise MLOps challenges? Okay, so I come across with a different different team members and a data scientist. The model, they build a wonderful model. It worked very well in their laptop, and the moment it go to the production, there are a lot of challenges faced by them. When bringing the model to the production itself, a big challenge, and how are they going to be monitoring the model? How they are going to scale the model, and how they are going to retrain the model and deploy the model. And we also have different personas where we need to work with the data engineers, as well as we need to work with the DevOps team who will build this model and go to the production. And it may sometimes they deploy in Azure Kubernetes, or sometimes they deploy in Azure Arc or the managed endpoint. So this is a different kind of skill set needed, which we cannot expect all the data scientists will master it and bring it to the production. Operation is a completely different paradigm of managing the machine learning, and how we can collaboratively work and provide the AI product as an enterprise. So this is a common challenges faced by most of the machine learning application built by the enterprises. Okay. And I think most of the people who are working in the machine learning or the machine learning operation would have seen this slide. And it's an iterative process, and MLOps comes from the wing of DevOps practices and culture. We adapted all the practices done by the DevOps, but we do also have a different level of life cycle for the machine learning. Like in a DevOps, we cut upon only the developers who develop their application and the operation production of the model. But as we seen in the previous slide, we have different personas involved here: data engineers, data scientists, and machine learning engineer. So this MLOps life cycle goes to the different level of iteration. So everything starts with the data. So everybody need to and anybody who working on the machine learning, um, definitely they need to start with the good data, and they explore the data. Then they will plan how to productionize this model. They package it and release the model and productionize the model. Okay, and this will go in iteration, because it once go to the model go live, that's not the end of the story. The real challenges begins there once the model goes live. How it is working in a real-time data, and how it is working in the real-time inference, or the batch, that really different from how it was tested before. Okay, and it always there will be a different level of accuracy, and some more data drift will happen. That's where we always need to uh, retrain the model based on accuracy. And if you're deploying a new model, if the model bringing down accuracy, immediately you need to go back, roll back to the previous version. These are all the part of the MLOps life cycle. Okay, and we also have a different framework, like a TensorFlow, PyTorch, and we can use a high-level API like a Keras and MXNet. And the way we are deploying in a model, like using ONNX or a different other native framework like a TensorFlow or PyTorch provide, it depends on your application and how we are deploying to the machine learning model into the production. Let me go to the first, and I'm taking out the four important parameter which is provided by Azure and which need to be taken into the consideration while we are building enterprise scale model. Okay, and the first one I want to iterate is we need to make sure we are versioning the code, data, and experiments. And like the development and the DevOps life cycle, we always version the developers code, as well as if you're building infrastructure as a code as well as a pipeline, we always version those code. The same way the MLOps, we have a model plus data plus code. So the data comes first. Of course, if you're building a model in the standard schema and in a sampling over time, let's say if you are using a time stream prediction, if you are sampling over the time, if so that all the things need to be matched. So we always make sure we are versioning the data. Okay, if you are looking at a small scale, like a regression, linear regression or logistic regression. If you're keeping in a CSV file, you can use Azure Data Lake and you can version it. Okay. And then we have the algorithm. Of course, it comes to the model. And every time you build a model, make sure you are versioning the model with the algorithm you used, what are the hyperparameter you used, and how many iteration you ran this, like epoch. All those information you need to version it, because while you are going to the next level of iteration, you need to compare the model. Okay, how come my accuracy went up while I'm retraining that simple epoch from 100 to 200, or how come the model accuracy went down the simple hyperparameter I made a changes. So it is always best practices to version the model. Then, of course, code, which is a business rate. Definitely, there will be business logic, like a small data processing involved, some custom processing based on a business logic, and some configuration file will be in place. Those are also make sure you are versioning it. Okay. The reason why we version is while the model is tested in a lower environment, like how we test our application in a dev or staging, the same way the model will be tested in the lower environment. Uh, we need to make sure it's all versioned and go into the higher environment. Okay, hope you all agree on this first step. Let me go to the next one, MLFlow. Okay, and anybody is using machine learning in your anybody is using machine learning library in your production environment or in your native application, you definitely have one or other open source product introduced. Okay, and particularly the version which I talked before, MLFlow is some kind of one of the industry best candidate to do track your model and track your experiments. And when the model is built, store the model into the particular registry and package the code in a certain format, which is a standardized format. And this is a open source. Okay, so it irrelevant of where you are developing and how you are going to person, it's open source. And particularly in Azure ML, it's tightly integrated with Azure ML. We will definitely go through those demo. Okay, and we will make sure, and whenever you are building a model, it track what are all the metrics as how much time it ran and what are all the experiment ran, what are the parameter we used, and it package the model in the standard format like a pickle or other standard format. And once the model is ready, it will be stored the model in the registry, so it can be consumed by as an API. So this is the best part of the ML flow. The third one, which I really want to touch upon, is a responsible AI. And everybody now talking about, okay, well and good, now we have a very good model ready, but how your model is fair, okay, whether your model is have all the all the inclusiveness. Okay, I'll take some example about the fairness. Okay, let's take an example of this. I think this screen is small, but the what we are trying to showcase here is it depicts the adult census income. Okay, and here it is an attribute of one of the attribute in the data, which is race, and you can see what is a privileged group and what is a non-privileged group, and it will show what is a deviation. Okay, what is a parity difference, and what is a as well as what is a gender, whether the male and female, how the statistic, what is the parity between that, and without medication what is the accuracy. And so once a medication is done, and what is accuracy, that once a medication is done, the accuracy went down between from 83 to 81. But that is, we are include, it's a fair model. Okay, because we including all the data is fair. Okay, so that is very important. Okay, then comes to the reliable and safety. The classical example for the real reliability and safety is you take as a self-driving car, and but we have a lot of model going inside the self-driving car for predicting the CV, computer vision, and getting and predicting in real time. So the model need to make sure it is reliable and safety. Okay, it's very important, and particularly on a healthcare domain, it is very much important. Let's say if you are and false negative and false positive, make a big difference in the medical in healthcare domain. Okay. Next comes the privacy and security, and this is very important in particularly in a zone where we have a different laws. While there is a prediction is happening, the data should not uh, uh, go to the application. Okay, it should be predicted on your device. And if there is a data mode, and that need to be make sure audited, and it need to have the data lineage and the data security other to that particular region. Then comes to the inclusiveness. That's what we have discussed before, and we need to make sure no one is left out intentionally, and we need to inclusive all. And particularly take an example of the speech recognition. Okay, and we have a different accent, and we have a different voice, like a male, female, child, children. Okay, so everything need to be included if there is any speech recognition software we are building. Okay. And definitely transparency. Let's say if you're building a model, and we are providing a model and building a product, and if your data officer is coming and asking how you come up with this model, and can you explain about your data, and what is the data sheet about your data, and can you confirm that there is no bias in your data? So your responsible AI platform need to bring down as a complete metrics how this was done. And accountability, of course, whatever we building the product, we are accountable. And example, facial recognition, if you're building any one, and it should inclusive of all the parameter we discussed before. And any enterprise model we are building, we need to make sure we are including a responsible AI. And Azure has a strong platform. We will see that particularly in our demo. Okay. Then comes okay. What if I say setting up the complete MLOps platform from end to end? Whatever we discussed before, version the code and build a platform for the data scientists to workspace like a Jupyter notebook or workspace to develop their model, test their model, and then once the model is ready, you need to go to the production. And what if I say there is a single click, or there is a quick way we can set up the complete platform end to end? Okay, and that's what we are going to see in a demo. And this is done by Azure MLOps V2 Accelerator. I have given the GitHub link here. Please go check it out. And it really provide value on it avoid any repeatability, and it bring a reliability, auditability, and definitely bring a very good data and model quality because everything is versioned and it has a very good process defined. Let me go to the demo. So I want to make sure I'm covering this uh, slide a little bit in detail, and then I directly jump into the demo. Okay, so this is a framework provided by the MLOps V2 Accelerator. It is done by the Microsoft team. And here in the first, we will start with the data. The data can be reside in anywhere. Okay, it can be unstructured data, which it can be running on the data lake. It can be stored in a Azure storage account, or it can be a Azure SQL database for the structured data, or Cosmos DB, or if it is a real-time streaming, it can be from the Event Hub. And also we can also store the dynamic data which is needed by the model in a future store also. That is the first part. The second one is administration setup. It is nothing but the workspace which is needed by the data scientists to work efficiently. So we need to have a repository where the code base like a GitHub, and we need to have machine learning workspace, example like a Jupyter notebook or IDE, and we need to have a connection to the data set in a approved authorized manner, and we need to have a compute to run the model, test the model, train the model, as well as we need to share our share our model with other team members. Okay, and as well as we need to make sure we are monitoring what we are trying to do. This is about the administration setup. The third part is the model development. Anytime the data comes, we need to do the exploratory data analysis, and then from the data we bring a feature which is needed for our model, and then we train the model. Then we want to make sure we are evaluating the model and make sure our model embed the responsible AI, so that we can see in a dashboard how our model did fairness. Okay, so this is a third setup, the model development. We call They call it as an inner loop. Then there is the outer loop where the model is going production. Okay, so before going to the production, definitely you will test it in your lower environment, and we do all the check, like a data check. We will do the unit test. Example, if there is a model accuracy went down in the model in a previous state, we take that particular data, which is predicted bad, and to see test with our new model how it is faring now. So that we will not do the overfitting or will not do the underfitting. We do the complete validation in six. The seven one is where the production, we need to make sure our model is scalable and flexible. It give elasticity, like if there is a huge amount of payload comes, it need to expand. So that's where the Kubernetes comes into the picture. And we can do the blue-green deployment, like using a manage endpoint. Azure comes with the predefined manage endpoints where you can deploy model A in, and we can deploy model B, and we can divert the traffic, the base percentage of that traffic we can do, and do the A/B testing, as well as we can do the canary deployment. Then monitoring, which is very important, which we are not going to touch much in today's session, but it's very important. If the accuracy goes down, it need to go roll back, and if there is a latency issue, it need to be alerted. So monitoring is very important. You can use the Azure Application Insights, which give the which comes in native with the Azure, will give you the metrics about your API output. Okay, so that's it about this session. Here we are going to jump into the demo. And before demo, I just want to give you the detail about where the source code. This is a source code where it exists. Okay, people really want to try out by themselves. You can go look at this GitHub, and they have a complete setup. It is with a screenshot in this document. And yeah, a few of the things I added in my code. Okay, if you really want to use it for reference, feel free, come and check on this, and you can see the some modification I did. Okay, I forked it from there and made some changes. And you can yeah, this is a lab demo I'm going to use, where you can go test try by yourself. Okay, so before okay, I'm going to jump into the demo, and I given a high level steps. Okay, and definitely I'll go walk through one by one step, whatever we are mentioning in the slide. Okay, so before, whenever you are starting to do this task, make sure you are build git clone here that particular repository which we have shown before, and make changes in this particular file. I'm going to show this file from the GitHub. So this is GitHub. I have cloned it. So sparse checkout.sh. Okay, this is not a source code. This is a boilerplate where if you once you run this one, it will create a particular repository to your native base. So you can only focus on this. If you particularly want to play around on multiple things, you can change it later. If you have multiple environment, also you can change it later. So infrastructure version, okay, whether you are going to use what kind of infrastructure as a code you are going to use, Terraform or Bicep. Okay, then project, what kind of project it is going to be. Every like a computer vision, NLP, or classical machine learning have a different type of infrastructure needed, the different life cycle needed, and based on your input, it will provide you the code. Okay, so the project type which we are choosing here is a classical, and the MLOps version. Okay, the CLI which we are going to use. Some people are very much fond of SDK. You can use the SDK, and if anybody, and by default, I'm going to use the AMI CLI version 2. Then Git folder. This is your local folder where the once the code is built, it will be stored here. And the project name, you can provide any project name, which is a Git, the the repository name and organization name, like how I given the BLR Reactor is my project name in a GitHub, and sorry, GitHub or organization name, and the project name is what I defined as a repository. And I'm given my the GitHub template that also by default will come with the Microsoft the sample code. You can keep as it is, but I made some changes. For that, I just rather than pointing there, I cloned it to my repo and made a changes. And orchestration, okay, how we want to deploy using a DevOps tool. Are we going to use a GitHub action, or are we going to use Azure DevOps? Here in our demo, I choose to both. I use a GitHub action as well as Azure DevOps. You can do both on the same place. Okay, just for the example, I have given both. Okay, so once this code is ready, you need to run the script. And once you run the script, what will happen? It'll create a repository. Of course, the sparse checkout is a new Git option, so we are expecting you to use the latest version. And this will create a repository like how it is created here. Okay, so this is what it is created. Okay, so here I want to touch upon a few important file. Okay, first file I want to talk about the config infra. Okay, so this file will talk about this particular setup we were trying to do. It will create a machine learning workspace. Okay, so that is what this particular file is going to do. Okay, and we can have multiple environment based on our requirement. I'll just open up the infra. Okay, so here what does it trying to do is it'll creating the workspace. And before we're creating workspace, we are running this particular YAML file from our Azure DevOps. So we need to give a permission to our Azure DevOps to create particular resources in Azure. So we have created a service principal connection. So the service principal connection is nothing but we are authorizing the particular Azure DevOps organization to go create a resource in Azure. Okay, so I can go show you my service principal before I am going to the next settings. So the service connection, I'm here. So I create a service connection with one for a development and one for the production, and as well as I created connection to the GitHub because I want to use the GitHub code to create provision the infrastructure. Okay, so let me come to the high level steps so we can follow along. Okay, so verify the export repo, and we need to make a changes. Okay, if you want to make a changes, any changes like a compute type or the name of your repo, and please come here to this particular file and make a changes. Let's say if you want the namespace with the prefix with your organization standard naming convention, you can come and make a changes. And if you need to be deployed in particular environment, you can change it in particular environment. Okay, now, then the next step is create a service connection. Yeah, I created a service connection. Okay, I shown you before. And the next step is deploy Azure ML workspace using Azure DevOps. Okay, here comes Azure DevOps. I'm coming to the pipeline and I pointed this particular code. I pointed the infra.prod.yaml file and I ran this pipeline. And what does it do? Then what it does is it create the resources. Okay, I'll show you the. I really don't want to run the pipeline on the exercise because it'll take a long time. So pipeline, so it created the resources. Stages. Created the storage for Terraform. Yes, this is where we are using Terraform. It will create a state file management for the Terraform, and then it will create a workspace. So it install, validate, and then it apply. So if anybody has good experience with the Terraform, they can easily understand what is it trying to do is it will try to pull the Azure Resource Manager provider, and it will create the Azure workspace. You can see it created a Azure workspace. Now this particular infrastructure You no need to go manually create how many infrastructure you want, or if you have a standard practice of each data scientist need to have one workspace, or each project team need to have different one workspace, you can go provision it and make sure that your infrastructure what you are provisioning is version controlled. Okay. Okay, fantastic. And again, all the code is under the same place. Okay, if you look at it, this is we are provisioning in the infra that is under the same code. Okay, now let us go and check what are the resources it's created. Created the two workspace, prod and dev. Okay, so let me go to the prod and see what go to the Azure machine learning workspace. So this is created via that particular pipeline, and Azure ML Workspace is a landing zone where you can find all the Azure ML related tasks like a creation of the notebooks and run automated ML, and you can create a pipelines. We will do everything via code. Okay. Now let me go to the fourth step. Review the data set, infra details, pipeline details, train.py, and MLflow information. So let me review the, this is the infrastructure, and let me review the code. Okay, so first we reviewed our infra.py file, which is needed. Then we understand the data set. What we are trying to predict today is we have, and this is an example given by Azure. I'm taking the same thing, and we are going to do the taxi fare prediction. Okay, predict the cost of the taxi of the two vendors based on your starting time and end time, and how much distance it's covered and what is the fare. Based on that, you'll provide the fare, and we want to validate whether the model is fair, whether the model is fair for both the vendors. Okay, we are going to predict that, and particularly which yeah, that is what this is about our data set. Okay, then we are going to check about our train.py, and in a train.py is under this particular file, and you can see our data scientists build in the model to train the, if they train the model using this, they are including all the hyperparameter information in the using a MLflow, and whatever the model output, their metrics, everything they are storing using a MLflow, as well as they are storing the artifact. Okay, it's nothing but a regression model, so they are storing artifact, and they will save the model which is under the registry, which will be reused again. Okay, so this is about the ML flow. I will go and show it from the console. I already trained the model via pipeline. How I trained using a GitHub action. Okay, so I'm coming here, BL, and you can train. You no need to go and use a different code. All the code is inside the same thing, and all you need to do is you need to use your file, that pipeline.yaml file, which is used to train. Okay. So here in the MLOps, you have Azure ML, and at the Azure ML, you have a train, you have a deploy, and sorry, 1 minute. My, infrastructure, pipeline, and this will provide you the what infrastructure we are going to use it for our pipeline, which branches we are going to use. It will go clone from the Azure template, and it will use the Azure template, and it will use a Terraform and use particular all the file to create all this workspace. This it will use the workspace which we are pointed to create the pipeline. Let me go to the show the actions, GitHub actions. Okay, here we use this train the pipeline. Okay, I click on the deploy model training pipeline. Okay, it ran the pipeline. It first registered the environment, created the compute, and run the pipeline. Okay, so update run ML pipeline. Okay, so we will see what it is running. Okay, it is using the file under the MLOps Azure ML train pipeline.yaml. It is using this pipeline to train the model. Everything I'm use a GitHub action. From here, I ran it, and it deployed the model on it. It created the pipeline in the target account. Okay. So here MLOps. I come here, MLOps, Azure ML. I go to the train and I go to the train pipeline.ml. So this will use a particular folder, the data, and use this and train the model, and it will give you the output of all the output. Okay. And it will give you the first, these are all the steps it will include. It first prepare the data, it take the input data and it train the data, then validate the data, test the data, and it store that particular environment which we are using, like what libraries we use as an environment. Then it train that model. It will train the model using the library and the environment we are using, and it will evaluate the model with the test data and registered the model. Okay, because we want to reuse this model, we will come to that last. Okay, then we are creating the responsible AI. Okay, it is using that particular output of the model as a and creating a responsible AI job. It first create explainability, then cache file. We will go through this in our in a UI, and counterfactual and error analysis, and it will gather all the information and store as a dashboard. So everything will be created by this pipeline. Okay, so if I come here to the Azure DevOps, here if I click on the pipeline, so in the Azure workspace, you can see this pipeline. Okay, it done all the task. Okay, it created the whatever we define in the YAML file. It ran through everything. Okay, it prepared the data and you train the model. You can evaluate, register, RAI, and counterfactual, everything it done. So in case if you really want to add any of the steps or any custom things, you can always come and change that particular pipeline according to your infrastructure and make a changes. So if you look at the pipeline life cycle, we set up our end-to-end infrastructure for the data scientist via code. We versioned everything. At the same time, we trained the model, evaluated model, responsible AI, everything we done. Again, it's all stored in the code. Okay. Let me come to the next step. Okay. Deploy the ML pipeline from a GitHub inner loop, and you can see it will pull the data, train the model, evaluate model, register model, check for the fairness and explanation. Okay. And the last is deploying the real-time endpoint for do some testing. Before going there, I will show you a few more things like a model. If I go to the model, uh, it will every time I training the model, it will version it. Okay, so that is natively come from the from the Azure. But if you go to the model, you can see this is a type we are using to version this model. Okay, and you can see what what is the library we were used, and what is the model name, what is the type we are using, and what is the library version we are using, then what are the hyperparameters we are using, and what is the artifact path. It give a complete lineage of all our model information. Okay, and that is the power of MLflow. While you are training the model, if you are including that MLflow library into it, and it give all this information to track your lineage. That's very important while you are running in a multiple running in an enterprise, and if you are working with a multiple data scientists in your organization. So the last step, okay, now in real time, it's not like one environment people have, and whoever trained the model will manage the model. In real time, people will train in certain infrastructure, but they will deploy in a different infrastructure, and the deployment infrastructure will be managed by the different team altogether. So previously, if any assets you are created, okay, take an example of any model you created. If you want to share it with the other team members who are going to deploy, they need to do the complete life cycle again, and that was addressed by the Azure in a scalable manner using Azure Registry. So what Azure Registry provides is, it when people are developing the model in one environment, they can share the model in the registry, and using the registry, uh, they can consume the model or environment as assets like a model, component, or environment. For the example of the environment is nothing but if you are training your machine learning pipeline using some environment with a particular package, particular version, we expect that particular version available at the time of your deployment. Okay, or if that same thing the other team members want to use it, so you can share that particular environment from one workspace to another workspace. And here component is same thing like in a code. If you have some custom library built which need to be used by other model or across the organization, you can share it to the registry and people can consume. You can, based on your access control, which workspace users can use, you can do it. And as well as what we discussed before is the model is very important thing, because we are interchanging between one environment and another environment to the deployment. Okay, so let's see the model also. Sorry for this. Okay, let's see the model. Here in a workspace, I'm giving you an example. In a workspace, we are in a production workspace. Okay, I built the model, everything. You can see the model taxi version 3 here. What I'm going to do is I'm going to provision another workspace under the we have one more workspace which we created. We are going to deploy them in that particular workspace. Before that, I have created a registry. So using this registry, you can share with the multiple region. That is one more very good advantage. Okay. So in this registry, I registered the model. You can see the resource group is this, and I registered the model here. View all models in this. You can see the model. And if I click on the model, you will see this information. It is under registry, and this is under this created by the job, and this is what it is under the different workspace. Now, what am I going to do? I'm going to deploy this model as a real-time endpoint in a different workspace. So I'm coming to the workspace, say development. It's a just naming convention I used. And what am I going to do? I'm going to the model. Here I don't have any model, but I created an endpoint from the model, which is from the different workspace, which is very much needed. So you can see I have created, this is a model. So if you look at this model, 1 minute, it is you can see the model ID. It is coming from the registry, and it is using that particular model which we share from the other workspace to here. And we have created only one endpoint, and the endpoint is ready. It's a managed endpoint. The same way you can use the Kubernetes to do the deployment also. And you can do the update traffic based on different model. You can do the update traffic also. Before going next, I deployed the model already. I want to test the model. Okay, so it will give a two output. What is the cost between the two vendors? Okay, so I come here. I am going to take a sample code test data. So in this repository, you can see it is this one used by the data science. This is by the data lives, and MLOps for our defining our pipeline, everything. And infrastructure is what we are used to provide our infrastructure. Here, I'm taking a request.json. This is already feature engineered and everything kept ready for the testing. Where is this? Okay, this is model. Okay, this is endpoint. Okay, no, we are in a different place. Okay, here it is. This is where our dev workspace, where we deployed it, and click on test. It'll give you the prediction. Vendor 1 is charging this and vendor 2 is charging this. Okay, so it predicted the value of between the vendors, how much they are charging. So this concluded our life cycle of how we are doing it end to end. And as we mentioned, we maintain everything under this particular source code, inclusive of creation of all the resources which we have done before. I'm coming to the last part, which it will take time to load. That's why I taken as the last part, which is a responsible AI. I will show it from the console, what based on our model developed. And the topic which we have not discussed is the model monitoring and data drift. It's for the different session. I'll come to the responsible AI. I come to the workspace and go to this model. This is the production workspace. I already have a model. I click on the responsible AI, and the AI it's already ready. Okay. It need a compute to do the analysis. You can see the screen. It will give you the complete details. Okay, so it give you the proportion means the error proportion, and what are all the, before going there, you can always check what are the feature it is selected. Click on it. 1 minute, sorry. Where is it? Okay, feature. You can click on the feature list. It'll give you the features which is used: distance, pickup location, and drop off location, drop off time, pickup time. All the information. These are all the information, and what is a vendor, whether vendor one or two. All this information will be provided, and then it provided the error analysis. Okay. Then it give you the model review. Okay, based on our data, it give you the mean square error and mean prediction, and it give you the error, and you can define which, based on what you want to do the analysis. If you want to use the mean square error to the error analysis, or are you planning to use a different metrics to the error analysis. And the data analysis, you can see the details about each index. What is the prediction? Okay, how much it is predicted. Okay, and future, what is the important future which played a pivotal role here? Distance. If it is predicting one number to the another number, which feature is playing a pivotal role? Okay, distance and a drop off longitude. Of course, based on the distance will be, and month date. If it is a holiday or it is going to be a peak hour, based on that, it will give you the cost will be varying. And counterfactual, it is based on your model prediction changes. Okay, if you are manually change some feature, what does it what value it does provide? Okay, it do all this analysis which is needed for our explainable AI, and you can export that as a PDF for a document. And this one you can do model by mod version, each and every model you are building. If we are building a model one, you can come and do this analysis, and if based, and you can compare the model, why it is predicting, and what made the model to give this output. You can predict everything using this. You can come to the complete fairness and the responsibility AI from this complete dashboard. Okay, so as again I mentioned, this also created as part of our pipeline. So it will be you need this compute to view this dashboard. So let me come to the last part. I think I'm well within the time. I covered all the topics which I want to cover. So again, I'm reiterating what we have come through. One is we need to version the data, and we need to have a good native integration about versioning our data model and everything. Then make sure your code is responsible, covers all the responsibility for enterprise, and build everything as infrastructure as a code. Use AWS, Azure um, uh, provided templates, which will be easy for you to set up. And the last, use the Azure Registry to share the assets between one workspace to another workspace, so your team can work in agile manner. That's all from my side, and I'm open to question. Um, thanks, guys. Thanks everyone for joining this call, and I'm open for the question now. But
Hey, Ayyanar. So, can you see the question on the screen? So,
oh, okay, I use Azure MLOps to monitor code DB outside. 1 minute. Hello, can I use Azure MLOps to monitor the code? DB means database. You are or what outside Azure? Okay. See, this one you need to deploy an Azure, right? Azure use a native Azure Insights to do the validation, monitoring. Okay. You can use any code. You can use a GitHub. Definitely, it has an integration with the GitHub. And the data set can be outside. Okay, you can consuming from your training the model. You can consume the data as an API also. Okay, example that Twitter. Okay, database. If it is from the different database non-Azure, you need to have a connectivity that will be come into the picture of during your data preparation and pipeline. So you obviously you can do it. Okay, but monitoring, yeah, monitoring you cannot do the database which is existing outside. Okay. As of my understanding, okay, I may be wrong, but as of my understanding, you cannot monitor the database running in your data center or something. Any other question, please? Any other questions? Further learning, yeah, okay, good. Okay, we can wait for another 1 minute to the participant to ask a question. Partha, apart, we cannot hear you. I think I'm not able to hear you.
Can you hear me now?
Yeah, I'm able to hear you now.
Yeah.
Yes.
Sorry, I muted myself. Okay, everyone. So before we call for a final call for the questions, please drop in from which city you all are joining in the chat section. Meanwhile, the questions come up. Okay. Any more questions or we call for a wrap? Good to know. We have one from Hyderabad as well. Okay. I think let's call for a wrap.
Okay. Thanks everyone for joining. Okay.
Thank
It's
you. Thank you so
nice
much,
record
Ayyanar, for a
opportunity.
wonderful session. Thank you all and enjoy the rest of your day.